Hello everyone, welcome to day, I think, 10 of Java coding. Oh man, we're on day 10. Uh, Today we're going to be going over how to make pipes and add those to our game. Go ahead and clean the whiteboard with the power of editing. Alright, so, okay, hopefully this time I don't make any more mistakes. So, this time you guys actually get to see the whiteboard in action, and my mic will not be muted. So, we just finished making the bird, right? And the bird class has all. I showed you guys how the physics work. I showed you guys how the drawing works. Now we're gonna apply the same concepts towards making these pipes. So what is the pipe, right? We're gonna have our box here, right? Our 100 by 100 frame, and we have our little bird here. We have to create basically two rectangles, which will both be drawn by the pipe. And let's see what kind of variables we're gonna have to add to our rectangle. Is my mic good, everyone? Okay, I hope my mic is good. Okay, now it's good. All right. So what kind of variables do we want? Well, we already have the height of the entire frame. That variable is called height. And so our code actually knows what height is, processing knows what height is, and it'll give us the height whenever we need it. That's one variable. What about this certain height here? How do we measure this height? Excuse me. Basically, up until we're gonna have a variable. Okay, let's start first with x variable. So let's just name this certain value x. Our pipe will have a value of x, right? And that's just going to be the starting position. And this little width here, we're going to name that W, right? We don't want to name it width, otherwise it'll get confused with the entire frame width. So we're going to name that W. What other kind of variables are we going to have to add to our pipe? We're going to have to add this height right here. It's the space. We're going to call this space, right? This is how low this space will be, and we're going to call this space width. So it's the width of the space. Now we could, we're going to randomize the space because we want to have a different space every time. We could randomize the width as well, but for now, let's just stick with measuring the width. Or let's just keep a constant width for now. Now you might say, hey, what about this part? Do we need a variable for that? No. And the reason is because we can represent this height as height, right? The entire height. If you remember math, this might this might hurt you a little on the inside. But this value right here is actually this total value minus these two values. So if you ever have, you never want a variable that's kind of redundant, that you can represent using really other variables. So, and we also want a velocity. And if you don't remember from last video, or I ended up cutting it out somehow, velocity is just how much our x will change over time. And so we'll keep that constant. And the reason we have a velocity instead of just changing the x over and over again is because if we just keep changing the x by constant amounts, it'll get really like staticky. It'll end up jumping across the screen, and we don't want that to happen. So now that we have that, let's get into the code. Okay, this is our little coding block here. This is where we left off last time. We're gonna create a new class, right? Wow. We're going to call it pipe. Alright, inside of this pipe file, we're going to say a pipe class. Now, what are we going to have? Again, we're going to have these variables that I just said. So we're going to have a float x, right, which is the x coordinate of the pipe, which will move across the screen over time. We're going to have a width, right? We're going to have a space, which is basically where this space starts. Where this space width will start. It'll just be another y coordinate, basically. A space width, right? We're gonna have also what else are we gonna have? A velocity. There you go. Float velocity. So we're gonna say we're gonna create our pipe constructor. Again, the first function that runs when we create our pipe. We're gonna say this dot x equals, let's just, we're going to start it at the width of the screen. It'll start on the very right, which is the width of the screen. we're gonna say not float, this dot w, we're gonna give it just a height of like 5 right now, which is just barely bigger than our Flappy Bird. This dot space. Now here's where a function called random comes into play. We're gonna we want our random space value but to be between 0, right? And we don't want it to end up at the height, at the width. We don't want it to be a random value between 0 and the width, because if space is over here, then the empty box that the bird can jump through is below the screen, and we don't want that to happen. So we're gonna say here's a cool a function that processing gives us, just again to simplify all the different syntax pieces that we have to use. It just gives us random. We're gonna start it at 0, and we're gonna end it at height, right? Height of the screen minus space width. Now you notice, not space width, this dot space width. Now you notice I messed up here because I declared the space, I used space width before I declared it. So I'm gonna say this dot space width. Let's just say 25 for now. It's around just like a quarter of the screen, just to give enough space for the Flappy Bird to jump. And we're gonna say this dot velocity. Let's just give it what, -3. And again, it's negative because it's moving leftwards. Now to have it move rightwards, we'll give it a positive velocity. But because we want to move left, we're giving it a negative velocity. So what kind of functions do we want it to have? We want to give it 3 functions. Now I will show you the 3. Obviously, when you're creating any object or anything that appears on the screen, any sort of different entity, we want to give it 2 functions: the update function and the show function. So update, inside of update, we're going to say this dot w, or this dot x minus plus equals this dot velocity. We're going to say, hey, just increase the velocity or decrease the velocity over time. And also we're gonna have the show function. This draws the rectangles. We're gonna draw 2 separate rectangles, and the rectangles function rect is very similar to the ellipse function. It gives you 4 values, right? We're gonna have it start. We're gonna draw the top one first, right? It'll have an x value, right? Rect, the 4 different values are its x, y, width, and height. So what's the x value? It's this dot x. What's the y value? We're going to start it at 0 because it starts at the top of the screen, which is height of 0. We're going to have it a width of this dot w, and we're going to have it its height will be the space value, how tall this space value is. So we're going to draw the second rectangle. So what is the height of this rectangle? What's the y coordinate? Or the x coordinate will just be this dot x again. The y coordinate will be this dot space, where the space starts, plus the width of the space. That will give you the end of the space. What else do we need? We're going to need the width and height. The width is still the same, this dot width. And the height, again, what is the height of this? It's the total height, which is height, minus this space, the sum of these 2 spaces. So we could say minus this dot space and minus this dot space width. That way, yeah, it'll draw in the right area. Now we need one more function, and all this function will do is tell us whether or not this pipe is off the screen. Once it's left, we don't want to keep creating pipes. Otherwise, we're going to have an infinite number of pipes that we don't want to deal with. It'll just stain our memory off the screen. So we want to be able to tell us, hey, is this off the screen? If so, we can delete it. So we're going to say this one's not going to be void. We're going to create a Boolean called off screen. Now, if you remember what this value here is, the keyword here, it's, hey, what am I going to return? So if this dot x is less than 0, right? 0 is the very left of the screen. If it's left of the screen, we're going to say return true. Return true. Otherwise, just return false. We always want to make sure we're returning something. So if it's true, return true. If it's false, return false. Now we're going to go back to our Flappy Bird class, and we're going to say, hey, Now, what do we want? We're going to create an array list. An array list is just a list of objects that have a variable length, right? And it has a variable length. A variable length meaning the length of it can change. Why do we want it to change? It's because we're going to be adding in pipes over time and deleting pipes over time. We can't do that with a regular array. So we're going to create an array list. So array list of type pipe, right? We're going to have a bunch of pipes, and we're going to call this variable pipes. So pipes will equal a new array list. So we're going to create an array list object that can store pipes inside of it. So it's just like creating any other object using its constructor. Now, here we could do it before our bird functions. We'll just say, okay, we're gonna have two different loops here. One to say, all right, update and show every single pipe. The second one will loop through and say, hey, if there's a pipe here we don't want because it's off screen, we're gonna delete it. So if you remember how to loop through an array list or even just a regular list, we say int I equals 0, right? We're gonna declare a counter variable, something that we can count with, and we want it to go through the entire list. So what is that? How do we do that? We're going to say pipes.size. Pipes.size is just the length of the list right now. How big is it right now? So in order to loop through all of it, we're going to say, hey, create this counter variable, have it go through every index of the list, and increase I over time. So I will, we're going to say pipes.get. That's how you get a certain value from this list of I. Now, imagine this as one of the pipes. So we can declare functions using this pipe. We're gonna say update it, right? And then show it. So we're gonna update and show every single value. Now, I will get into a very important concept very soon. So we're going to declare another one to loop through all the pipes again. Now, why didn't I just combine the two? Well, let's go to the whiteboard. So, I'm not going to erase all this. I'm going to use this space right here. So you have your list of items, right? I'm going to just say, give it 3 spots right now. 0, 0. 0, 1, 1, and 2. These are objects, right? They're integer objects. They have the index of 0, 1, and 2. 0, 1, 2. Now let's say we're looping through all of it, right? And our loop will say, all right, start at I equals 0. Oh, you can't see that. Equal 0, right? Then I will equal, go to, it'll increase, right? Go to 1, and then 2. Now, the length of this is 3, right? The length of this is 3. There's 3 things inside of it. That means it'll go up until 0, 1, and 2. It won't go until 3 because 3 is not less than 3. It's equal to 3. So it'll go to 0, 1, and 2. Now, let's say we want to delete one of these because it's off screen, right? So we're starting at 0. We're going to 1. And what if 1, we have to delete it? So we delete 1. Get rid of it, right? Our new list is 0, 2. Now you notice something. We hopped. We went here. We went here. Now we're at here. All right. I equals 2. But the thing is, our list, the length is now 2. So it'll skip over 2 completely. Now the danger of that is, what if 2 has to be deleted as well? We just missed deleting 2 because when we deleted 1, we moved the index over. So we want to avoid that. How do you avoid that? The best way is to loop through this backwards. Because if I say, hey, start at 2, then go to 1, then go to 0, if I delete 2, I'm still going to 1 after that. And I still check number 1. And then after that, I still check number 0. So we have to avoid index skipping. All right, so let me show you guys how to do that. Int j, we're going to declare a new counter variable. Again, the name of the counter variable doesn't matter. I'm just picking really small variable names. So we're going to start it at the pipes.size minus 1. We want it to have the index of the last variable. And the index of the last variable is pipes, the length of the variable, minus 1. because we're starting our count at 0. We're gonna say I is greater than or equal to 0, right? As long as it goes up, as long as it goes to 0, as long as it goes to 0. All right, and then oh, not I, j is greater than or equal to 0, because we want to include 0. That's a part of the index. And j plus plus, or j minus minus. We're going backwards, so we want to decrease. So pipes, it's very similar very similar process. We're going to say, hey, is pipes dot get of j, which means is this specific pipe less off screen. So we can say off screen because we made a function off screen. If that is true, right, this gives us true. So we don't have to say equals equals. We could say equals true, but this is the exact same thing because this gives us true anyways. If true equals, if we say equals true, we're saying, hey, is true true? And if true equals true, it'll give us true. All right, if that confused you, don't worry about it. You can just skip equals true for now. Excuse me. So if it's off screen, we can say pipes dot remove j. And if you remember what remove j is, excuse me, it says, hey, remove it, this specific index of pipe. So now we're adding and removing pipes, and we're updating. Oh, I missed one thing. I forgot to add in pipes. Okay, so we're gonna declare one last thing. All right, I know this is a long lesson. Let me just try to finish this. We're gonna say our count. We're gonna declare a counter, right? Now, why? It's because we want to create pipes at regular intervals. What a regular interval is just I want to create a pipe every like 10 seconds or every 10 frames. And so we do that by saying int counter equals 0 if counter modulus like 50, right? Oh, that's not a modulus. Modulus 50, if counter is divisible by 50, what that means is, hey, if I'm increasing counter like one by one, counter equals what, 0, 1, 2, 3, 4, 5, 6, 7. Every 50, every 50, as counter increases, at every multiple of 50, the counter modulus 50 will equal 0, right? Modulus is the remainder. So at every multiple of 50, if I divide by 50, the remainder will be 0. So I want this to happen every 50 frames, right? I want to say pipes dot add new pipe. So again, if you call on the constructor, say new pipe with parentheses, you're creating a new object right there. So I'm creating an object and I'm putting it inside pipes by adding it. Now I'm missing one thing, and that is I want to increase my counter by 1 every frame. Otherwise, counter will always equal 0. It'll always be a multiple of 50. 0 is a multiple of 50. It's 0 50s. And I'll be adding in an infinite number of pipes. So I want to increase my counter. So I missed one more thing. Let's just go back here. I forgot to say fill 0, 0, 0. All that is hey, I want to color my rectangles. Otherwise, they'll come out white and it'll be the same color as the screen. So let's run this. Oh no. So let's run this, and this is what I got. I got this, oh no. Where did it go? Okay. So it's a little bit laggy. That's just because I'm running a bunch of programs right now to stream my software. I'm running processing. So you'll see that it's going very fast, and I can decrease or increase the velocity however I want. So if I wanted to decrease the velocity, right, I could just go here and say velocity minus equals -1 instead. So let's run this instead and see how it goes. Now it's a lot easier, right? I guess. I'm still really I was always really bad at this game. So if you guys you can test yourselves. Now we're done creating the pipes, right? We're done creating and drawing the pipes. Next time we'll be looking at how do we add a collision, right? Because we want you know, we want a game over. We don't want this to just go forever. We're gonna add a score, collisions, and I guess, yeah, just more graphical properties, more things that you guys can add in for fun. So, thank you guys so much for watching. Uh, this lesson has been a lot of fun. We'll keep working on it, and I hope you guys enjoyed it. And I will see you guys in the next video.